Alright, welcome to today's lesson on arrays. Now the first thing we need to talk about today is, well, what is an array? And in order to answer that question, we have to first answer the question of what is a variable. And if we go back to one of our earlier lessons this semester, we can remember that a variable is a symbolic name for a location in memory used to store data. If you don't remember what I'm talking about here, we might have an example to help us. An example here is we've got an integer. So this is type integer, and the name of this variable is called age. And what this variable does is it sets up a location in our computer's memory to store an integer value of a person's age, so like 17. And it calls that location in memory age, so it can easily go back and access that value of 17 to be used in a program. Well, an array is essentially the same thing. It's a location in our computer's memory, but instead of storing an individual integer value, it's going to store a set of items of the same type all under one name. So again, for example here, this time I'm going to have an integer array, and that's represented by these square brackets that tells me I have an array. And what this is going to do is it's going to set up a location of memory just like my regular variable, but this time instead of storing one age, I'm going to store a whole set of data in a location that I've called student ages. Why would I want to do this? Well, first of all, I can have a single location or a single variable name representing a large amount of data, which makes it very easy for me to access a whole bunch of data all at once. Secondly, even though I have all this data stored in one place, I can still very easily access individual items of data, which we call elements. So I can figure out the third age is 12, the seventh age is 15, and so on. And finally, even though I can access each element individually, because they're all grouped together in one variable name, I can very easily do operations on the entire set of data. So a couple of random things that we might want to know about working with arrays before we get into how to actually use them. The first is that items in an array are referred to by the name of the array and their position in an array. So I might have values in an array of 13, 12, 15, and so on. And just like when we worked with strings, where if I had this was my string here, array factoids, I had positions of each character starting at 0, going 1, 2, 3, and so on. The same thing is true for elements in my array. Each one has a position 0, 1, and 2. So if I want to access this particular element, I'll be looking at my student ages array position 2. And I'll show you how to do that in code in a couple minutes. So that's what we just said here. An element's position in an array is called its index. So that's called index 0, index 1, index 2. And the numbering, just like we talked about with strings, starts at 0. When we try and store data in an array, it's good to know that we can store absolutely anything we want in an array. You can have primitive data types like integer, double, and so on, and we can have any type of object. So we could do an array of string buffers, an array of string tokenizers, an array of strings. Anything we want can be stored in an array. The only catch is that all elements in an array must be of the same type. So I can't have an array that has both integer values and double values. They have to be the same. And finally, because an array itself is an object, we can't have its length altered after we create it. So once I've decided I'm going to have 5 elements in my array, I have to have 5 elements in my array for the entire time that array exists. I can't make it any longer or shorter. I can change individual elements in the array, so I can change the values of certain variables in the array, but I can't make it longer or shorter by adding more or less elements. So how do we do this? How do we actually code for an array? Well, there's 3 things we need to do when we're going to use an array. First, we have to declare it, just like we declare any other variable type. Okay, what this is going to do is it's going to tell Java that I'm going to have an array of this type of variable. The second thing we do is memory allocation. We have to give the array a size. We have to tell the computer that I'm going to have 15 elements in my array so that it can set aside the right amount of space in memory to store that information as we give it to it. And then finally, we actually have to give the values for each element in an array. This is called array initialization, where I've actually started giving it values and filling it up so we know what information is being stored in that variable. So to declare an array is like declaring any other variable. All we have to do is write the type of information that I'm going to store in the array and the name of the array. So like this, int student ages. So this particular case here int student ages is just going to give me an individual variable like I would have for a single integer. But because I want this to be an array, I have to add the square brackets beside the type. So I'm going to have an integer array called student ages. So this is the individual variable, this is the array declaration. Once I've declared my variable, I now need to try and allocate memory. Okay? When I declare an array, it doesn't actually create it. It doesn't set aside any memory or anything like that. I have to actually do this during memory allocation. And it's the same thing as we used for when working with a constructor for an object. I have to say I'm going to have a new integer array. Just like before I had to say I have a new string tokenizer or a new string buffer. I have to do the same thing. And when I do it, inside the square brackets here, I have to provide an integer value representing the number of elements that are going to be in my array. I could hardcode this as an actual number, or I could provide this as a variable. Okay, as long as that variable is going to be evaluated as an integer. So this particular example means I'm going to have 12 elements, and at this point in time the Java virtual machine is going to set aside the memory so I can store the information. Okay? And as I said, the number inside the brackets can be a number or any other variable that evaluates back to an integer number. If the programmer knows how many elements we're going to have in advance, so if I've already figured that out before I'm going to actually declare my array, I can do those two steps at once. So I can say I'm going to have a string array called student names. It's equal to a new string array of 5 elements. So I can combine those two lines together into one. Okay. What that would do is it would create an array called student names, and I'd have 0, 1, 2, 3, 4 as my indices or my positions for the pieces of values or the pieces of data that I'm going to put in there. Okay. So now I've created that array, I've set it aside, I actually want to put information in it. I do this by filling the values one element at a time. So student ages at position 0 is going to be 16. So this will place this value inside the array at index 0. Okay, index 1 will be 16, index 2 will be 15, and so on. So now my array looks like this. I've got indices 0, 1, 2, and 3, and I have my pieces of data, so each one has its associated value. Okay, those are the contents of the array. So again, we can combine this in the previous step if we know the information in advance. So I'm going to have a string array called student names. My student names is going to be a new string array, and this is the data I'm going to put in it. This is called an initializer list. In this case, I don't have to state how much data I'm going to have, how many values I'm going to have. Okay? Instead, it looks at this list held inside the squiggly brackets, and it's going to create an array of 2 values and have them filled with their contents all at once. Okay, another example here, working with integers. This will create an array of 1, 2, 3, 4 elements put into an integer array that we've called student ages. Again, this here inside the squiggly brackets is called an initializer list. So once I've created my array, I can start accessing elements from it. And if you remember from earlier in this lesson, we do this by saying the name of the array and the position of the element we want to access, okay, which is called its index. Remember, the array index must always be an integer value. Okay, it's position 0, position 1, position 2. There are no half positions. So, student ages 5 will allow me to access the 6th element in student ages. Remember, we're starting at numbering from 0. So 0, 1, 2, 3, 4, 5. This is actually the 6th element. 1, 2, 3, 4, 5, 6 elements. Position 5. So what position would this give me? If you said it's the I plus 1 element, that is correct. So if this I was a 3, it'd be the 3 plus 1 or 4th element. 1, 2, 3, 4th, position 3. So what position would this give me? Which element would this code give me? And hopefully you've picked up the pattern here. It's going to be 10 times I plus j plus 1th position. Right? 10 times I plus j is whatever this evaluates to. Whatever that evaluates to, plus 1 because we start our counting at 0. What would this one give me? For those of you who say, I have no idea, well, it's because that gives you an error. We can't have negative positions. If we start our counting at 0, I can't count negatively. So this would give me an error. It has to be a positive value. So here's a particular array I've got. Again, my indices are across the top, the values I have are underneath. I'm going to show you a little bit of code, and what I want you to do is tell me what the value is going to be at the end of the code. Okay? So what would this following code here give? Pause it, figure out your answer, and then I'll tell you what the answer is. In this case, it's going to give me the value of 7. So 3 plus array at position 3. Position 3 is up here. That's going to be a 4. 4 plus 3 is 7. So I'm going to print out the answer 7. What about this code? So here, what I'm going to do is I'm going to get value 8. So I have array at x. There's x. X we said before was 7. So position 7 is all the way over here. It has the value of 10. And I'm going to add to it array at position 5, which is negative 4 divided by 2. 4 divided by 2 is 2. Right? Or negative 2 because it's negative 4. Right? 10 minus 2 is 8. Or 10 plus negative 2 is 8. I'm going to store that in array position 0. So this now is going to get crossed out. Has an 8 in here. And I'm going to print the contents of it, so I print to the screen an 8. Before we go, I'm going to show you a quick program that has all the array stuff we would need to use in it. So in this example here, what I'm doing is I'm going to declare a string array called names. I'm going to ask how many students are in the class, and then I'm going to allocate the memory. I'm going to say my names is a new string, and I'm going to read the answer, the integer answer that they give me, and this is going to be used to allocate that many elements in my string array. Then I'm going to loop through my entire array, so starting at position 0 or index 0, going up to the length of my array. So this is interesting here. This tells me my length of array. So whatever my array is, dot length will tell me the length of that array. I don't need to use brackets because it's not a method, it's just an attribute or a piece of information about this array. So I'm going to go through all the elements of my array, going one at a time, where you're going to give me a student name, and I'm going to store it in my array. Then I'm basically just going to print it back out to you. So I'm going to go through all the elements of my array again and print them off for you. So if I run this, I'm going to have 3 students in my class. Who are some students in my class? So we've got Unib, we have Marus, and who else is in our class? We've got Susie. And there's our class, Unib, Marus, Susie, and we're done. That's it. That's all we've got for today. We'll see you in class tomorrow where we can talk about what we've learned.